All right, so now we're going to be working with this network security data. Some things that we're going to cover in here is this common data platform and how the data is prepared for use on this network security monitoring system. We talked about Security Onion, which are now we're going to implement those tools to investigate those network security events, and then describe the network monitoring tools that enhance the workflow of this management. So as a common data platform, Security Onion is going to use the Elastic Stack, which consists of ElasticSearch, Logstash, and Kibana, commonly known as ELK or ELK. This is going to be core to try to collect all that data that we've been talking about in other modules and get it into one interface. So in the Elasticsearch, this is an open core platform that's used for searching and analyzing an organization's data in near real time. Logstash is going to enable collection and normalization of log data or network data into data indexes that can be efficiently searched by Elasticsearch up here. And then Kibana is going to provide a graphical interface to that data that's compiled by Elasticsearch. You also have Beats down here, which is just a series of software plugins that send different types of data to the Elasticsearch data stores. So the idea here is to reduce the data and get everything normalized so that you're not having to search through a bunch of different systems. And so the idea here is that all your packet captures, your syslogs, and your alerts, everything's going to get funneled into your ELK combination, and that's going to send out the relevant NSM data that ends up going to SQL that we talked about before. So by limiting this volume of data, tools like Elasticsearch can be far more useful. You don't want to get a bunch of frivolous data, otherwise your Elasticsearch is going to get filled, the database, and then it has to index it quite a bit, and therefore it's going to slow it down. So for data normalization, this is the process of combining data from a bunch of different resources into a common format. And so a common schema for specifying the names and formats is the required data fields. So for example, IPv6 addresses, MAC addresses, and date and time formats can be represented in different formats. We all know that we can see this notation here. We can also see it in dash notation as well as the dot notation. And then date formats all come in different ways of getting that data in. So the idea here is that we're going to normalize this down to one specific format. We'll take in a bunch of different sources and put it down to a one single style format. So retaining this data indefinitely is not necessarily feasible due to the storage and access issues. You can't, retain information forever. And therefore, retention period for certain types of network data information can be specified via the compliance frameworks. This will be specific to, like, for example, NIST frameworks. SQL alert data is retained by 30 days by default, and this value can be set in the securityonion.conf file. That Security Onion data can always be archived to external storage by a data archive system, depending on the needs and capabilities of the organizations. And so the storage locations that are different types of Security Onion will vary based on this implementation that you have deployed. Because the Security Onion implementation that we have deployed is all on one system, everything's being stored on this single drive. And so one lab that you'll have here is being able to convert data into a universal format. You'll go through those log entries and how to do that and get that normalized. All right, when you go to investigating the data, again, you'll start in SQL. And so that's the first place that cybersecurity analysts will go to verify alerts that are in there. SQL will automatically start correlating similar events into a single line, and that will provide a way for correlated events to be represented. So again, remember this count here, this C and T line is how many that are correlated together. To understand what's happening on the network, it must be useful to sort this count network column here in order to display the alerts with the highest frequency. So as we can see here, there's been 1,059 alerts that have all correlated to the same type of incident up here. For SQL queries can be constructed within here using the query builder. This is going to help simplify constructing queries into a certain degree, which is what you see up here at the top. So a cybersecurity analyst must know the field names and then some issues within the field values to effectively build queries within SQL. This is the most important part that you can try to figure out, is knowing these different fields so that you can retrieve what you want. Notice that it's very SQL looking like, or SQL statement like. So select different events from different things and then join different events. These are almost identical to SQL statements. So for example, SQL stores IP address information in that integer representation. So SQL will provide the ability for the cybersecurity analyst to pivot to other information sources and tools. So log files, for example, are going to be available in ElasticSearch, and you can go back through and tie into that. Relevant packet captures are going to be able to be displayed in Wireshark. And then you can also provide pivots to a passive real-time asset detection system, or PRADS, or you can also go to a security analyst network connection profiler, SANCP. The SQL interface refers to pads as opposed to a PRADS. So event handling in here, this console is going to enable us to investigate, verify, classify different alerts. There's 3 different tasks that can be completed in a SQL to manage alerts. The alerts have to be found to be false positives and can be expired. The event can be escalated by pressing the F9 key, and an event can be categorized as you see there. So difference includes the 7 pre-built categories that are assigned by using the menu or pressing the corresponding function key. So you can see these different categories here, and you can press the different F keys in order to classify those. When you're working within ELK, remember that logstash and beats are used to bring all the data ingestion into the ELK stack. Kibana is going to be this visual interface to all those different logs, and it's configured to show the last 24 hours by default. So logs are ingested into the ElasticSearch database and then separated, and databases can be based on configured time ranges. The best way to monitor data in ElasticSearch is to build customized visual dashboards. So you'll want to build different ones that are key to your particular network and things that you're wanting to look up and alert on. So queries within ELK, ElasticSearch is built on the Apache Lucene, which is an open source search engine software library featuring full text searching and indexing. Using the Lucene software libraries, you have Elasticsearch, which can build its own query language. It's kind of based on JSON and is called Query Domain Specific Language, or DSL. Along with JSON, Elasticsearch queries can make use of elements such as Boolean operators, fields, ranges, wildcards, regex, fuzzy search, and text search. Elasticsearch was designed to interface with users using a web-based client that follows the HTTP REST framework, and therefore methods for executing the queries can be done over URI, C-curl, or JSON, or even DevTools. There's a bunch of advanced queries that you can do beyond the scope of this course. The labs are just going to provide you with the complex query statements when necessary. The investigating process as you go through here, applications will interact within the operating system through system calls or the API, the system API. If malware can fool the OS kernel into allowing it to make system calls, many exploits are end up being possible. So OSEC, which is one of your HIDs, it's the host-based intrusion detection. Those rules can detect changes within the host-based parameters, and then OSEC will trigger rules based with an alert back in SQL. Pivoting over to Kibana, you can then use the host IP address, allowing you to choose the type of alert based on the program that created it. And then you can filter that indice based on the results that are available in the view in order to occur on that host. And so you can kind of detect all the different malware that's going on within that OS kernel. If you're going to investigate different file details here in SQL, if a cybersecurity analyst is suspicious of a particular file, that hash value can be submitted to an online site to determine if the file is known to be malware. In Kibana, Zeek hunting can be used to display information regarding those files to the inner network. And note that inside Kibana here, the events type is set to Bro files, even though the new name for Bro is Zeek. So try not to get that too confused here. Again, Bro was the original name of the program. It was recently renamed to Zeek. All right, so you guys will have a lab based on regular expressions here. For those of you that haven't done much in regular expressions, this might be your first time. If you have gone through the Python course, you should have a little bit of exposure to regular expressions. Every type of system uses it slightly differently, so I encourage you to go through this tutorial. This lab is fairly short. You're just going to go through and build out some regular expressions. You'll also go through and extract some data from a PCAP file. And so being able to look at logs is important, but you also need to know what's going on real time within the packet capture. And so it will take you through a previously captured PCAP file and be able to extract that executable file from that traffic that's being collected. We'll skip the video. That should be there in your section. This is going to help you interpret the HTTP data and DNS data to isolate a threat actor. So you're going to investigate a SQL injection as it's going on, that DNS exfiltration, and then exploits using those security onion tools. And last but not least, you're going to go through a lab that will help you isolate a compromised host using the 5 tuples that you guys have learned. Remember, the 5 tuples are your source and destination address. You're going to have your source and destination port, as well as your IPv4 or IPv6 indicator. These last 2 labs you won't be doing inside of here. So enhancing the work of the cybersecurity analyst. Remember that we have the dashboards. And so these dashboards are going to provide a combination of data as well as visualizations, which allow you to focus on the specific details and information. Dashboards are usually interactive, and therefore Kibana includes some capability of designing custom dashboards. In addition, tools such as Squirt within Security Onion can provide a visual interface to that same NSM data. Workflow management. Again, as a cybersecurity analyst, you're basically collecting all this information, putting it together, and then analyzing that data. And so you always have a workflow that goes through there. And these are going to be the sequence of processes and procedures that you're going to work through your tasks on a daily basis. Managing these little SOC or security operating centers workflows is going to enhance the efficiency between the cyber operations team. It's going to increase your accountability of your staff and ensure that all potential alerts are treated properly. So SQL is going to provide a basic workflow management, but it's not a good choice for large operations. There are tons of third-party systems that are available that can be customized for your particular SOC. Automated queries can add efficiency to the cyber operations workflow. Those queries automatically search for complex security incidents that may evade other tools. All right. So to summarize this particular section, a network security monitoring platform such as ELK or the Elastic Stack is going to unite all the data together from all the different systems. ELK is going to consist of the ElasticSearch, Logstash, and Kibana with the components of Beat, Elastic Alert, and Curator. Remember, those are the different ones that will go out and trigger the alerts. All of that network data must be reduced so that its relevant data is only processed by the NSM. And therefore, we need to normalize that data by converting those same types of data to consistent formats. So there's various ways to represent IP addresses and MAC addresses and date timestamps. We need to normalize that to one particular type. And then SQL is going to be the console that provides you guys the initial investigation, verifying, and classifying of alerts. Kibana will give you a visualization of those into the insights of the data with large amounts of data being represented into a single format. That workflow is going to add efficiency to your work team. So getting all these tools set up and understanding their correlation to one another will definitely help you get all this put together. Some of you may have already worked in help desk type scenarios, and so you're a little bit familiar with working with multiple systems all at once. We haven't talked about like a ticketing system, but that's also integrated in here as well, so that you can stash that alert off, and then every month you go back through and review your security alerts. We'll cover that here in the next module.